Hello viewers, this is your chemistry teacher, and as you know I've been giving you the lecture on polymerization in organic chemistry of O levels. Now this is the topic of macromolecules. Now a macromolecule is a very large molecule that is made up of many small molecules. Now a polymer is a type of a long chain macromolecule that is linked together by many small repeat units called monomers. So monomers are the actually main units, single units, which actually join together to form a larger molecule that is called polar molecule. If M is the symbol of monomer and N is the number of monomers, then it can be represented as M in bracket N, and the equation can be Nm, that is number of monomers, and when they are attached together in the form of a chain, we write it on this and number of N outside. Polymers are usually in the form of long chains linked together. I have drawn over here to show you just how they are arranged. Now these are the long chains and these are the cross links between the chains, and the small circles, they are actually showing the monomers. Some polymers occur naturally like starch, cellulose, latex, proteins, DNA, etc. Some polymers are man-made, that is artificial, like nylon, terylene, polyethylene, Teflon, etc. Now we are going to study polymerization, the process of joining large number of monomers to form a polymer is known as polymerization. Now these I have shown you the monomers. Now mono means one and mer means unit. These are monomers, and here I have joined all these monomers, and the single line in between is actually showing the covalent bond, and this forms a polymer. Poly means many and mer means unit. There are two types of polymerization: addition polymerization and condensation polymerization. Addition polymerization, it occurs when unsaturated molecules join together without a loss of any molecule or atoms. The polymer formed is called the addition polymer. Now I have done the formation of polyethylene in detail while doing the topic of ethene, that is when I uploaded the lecture of alkenes. I have discussed this addition polymerization in detail over there. Now here I am going to give you some examples of addition polymerization. First example is of this propene. Now why I am calling it propene? Because you can see we have 1, 2 and 3 carbon atoms, and there is a double bond between these two carbon atoms. This carbon has 2 hydrogens, this has 1 methyl and 1 hydrogen group. N number of propene molecules, when they join together, this is actually the polymer formula. I am broken down the bond from here, double bond, one single bond, now there is a single bond, and this double bond, half here and half here, that is one covalent bond, as I have explained earlier, has 2 electrons. So we break this from here, it is going to form one covalent bond over here and one covalent bond over here, and this is the formula of the polypropene. I have written N over here because these N can go to thousands in number. This is another example. This is phenyl ethene. Just remember the formula C6H5, it is phenyl. No more of its you should be knowing details. 2 carbons, ethene. So this is phenyl ethene. This is its formula, and when it makes a polymer, it is called polyphenyl ethene. It is used in packaging and sealing tiles. Then we have, this is again ethene. 1, 2, 3, 4 fluorine are attached. This is tetra. Tetra stands for 4. Tetrafluoroethene. This is its formula, and it is used in non-stick saucepans, bridges and bearings. This tetrafluoroethene is also called Teflon. Now you can find non-stick pans in your kitchen. Now this is CN, carbon and nitrogen. This is actually a nitrile group, so this is called acrylonitrile. This is its formula, polyacrylonitrile. It is used in synthetic fibers for carpet, clothes, etc. Then we have methyl methacrylate. Don't be confused with these names because you don't need to understand their chemistry. Just I am writing down the name. Neither you don't know, remember, you don't need to remember their names also. This is just for you to see that this is ethene molecule, this is methacrylate. This is how it is going to change into its formula. This is what is important for you. You are going to break the bond from here, and you are going to put these on the top and these two at the bottom. Put a square bracket and write N. This is important for you people at this stage. This is polymethyl methacrylate. This is normally known as Perspex. This is a glass substitute actually. Now the important thing for you people at this stage is reducing the structural formula of the monomer. First step is identify the repeat unit. Now this is one chain I have drawn. Now you can see, if you clearly see, follow these carbons over here and see the topmost groups attached on it, or over here. Now at lower part they are all A, so you don't have to worry about them. On the top, one carbon has H, another carbon has OCOCH3, then again carbon has H and OCOCH3. So you can see that this is actually, this one is repeating this one and this one is repeating. So this is actually the repeat unit. Name polyphenyl acetate. Now write down the formula of the repeat unit. Once you have identified the repeat unit, write down its formula. This is the formula of the repeat unit. And now another part, that is write, third part, last of it, that is write the structural formula of the monomer by converting the carbon-carbon single bond to double bond. So this single bond I have converted to double bond over here, vinyl acetate. Now this is another example. Identify the monomer. Again, look at all the carbons, find out the sequence, and you can see each carbon has fluorine attached. So we are going to pick out this repeat unit, this repeat unit, this repeat unit, and I am writing out over here the repeating unit, and this single bond is written as a double bond over here. Now this was all about the addition polymerization. Now we come to the condensation polymerization. It is the linking together of monomers with the elimination of a single molecule like water. Each polymer may contain two kinds of monomer molecules. Now remember, in addition polymerization, we had said that there is no loss of any molecule or atom. But here, when the two monomers are going to condense together, a simple molecule like water is eliminated. Each polymer may contain two kinds of monomer molecules. Now, condensation polymerization can be divided into natural and artificial. Natural, we have protein, and the same linkage is found in the artificial polymer, which is nylon, and the linkage between them is similar. That's why we are putting them together. And this is the amide linkage, C double bond O, N and H. This we are going to discuss in detail. Second condensation polymer is fat, and artificially terylene. When I am going to discuss them, fats are actually the macromolecules, that is the large big molecules, but they are not polymers. Fats and terylene. Terylene is a polymer, and the commonality between these two is this ester linkage, C double bond O and O. Then we have carbohydrates. Carbohydrates are natural, and glucose molecules are linked together, condensed together like this, and these are the oxygens in between, and this is glycosidic linkage. Now we come to study one by one. First of all, we are going to study proteins. Now proteins, monomers are amino acids. This is the general formula of the amino acid. This is the amino group, that is H2N. This is a carboxylic group, COOH. This is the rectangle in between is actually part of the monomer, which is a hydrocarbon, and there can be other groups attached to the hydrocarbons. So we need not go into the detail of the structure of the monomer inside or the groups attached, so we just draw a rectangle. And in order to show different monomers, we actually draw the rectangles like this in different colors or the way you find. Now this is I have not drawn any line over here, and this I have shaded just to show that these are the different parts of the monomer inside. But the similarity between both of them is that this has a carboxylic group, amino group, carboxylic group and amino group. So when they condense together, hydrogen from the amino group and OH hydroxyl group from the carboxylic group are removed, and they are eliminated as a water molecule. So this is, here I have joined them together, and you can see this is the peptide linkage in between them. So this is called a dipeptide. Now we come to more detail, that is amino acid plus amino acid forms condensation. When we are going towards this side, it forms a protein. When large amount of amino acids are joined together, they form a protein with the removal of a water molecule from each parts of the condensation monomers. And if we go back, it is hydrolysis, that is when we break protein into amino acids, it is called hydrolysis. Hydrolysis is reverse of condensation, that is we add water and break the protein to amino acids. Example is digestion, and this happens with the help of enzymes in our body. Now we come to nylon, which is the artificial polymer. Natural one is protein and the artificial one is nylon. Its monomers are dicarboxylic acid and diamine. Dicarboxylic acid, you can see one carboxylic acid on one side and this on the another side, and diamine, di means two, so one amino group on this side and one amino group on this side. So when they both condense together, this is a dicarboxylic acid, n number of dicarboxylic acids, n number of diamines, AH of the amino group, OH of the carboxylic group. They are removed as a water molecule, and this is the linkage formed inside them, which is actually the amide linkage, and this is actually common for the proteins and for the nylons. So the repeat unit of nylon is this one and this one, and you can see over here now this is the repeat unit, and nylon is a polyamide as it contains many amide linkage. So protein is also a polyamide because it also contains many amide linkage. This is the amide linkage. You must remember the amide linkage, and there are questions given in your papers how to differentiate between the polymer chains, whether it is protein or nylon. So you can see this I have drawn. If you can clearly see, this is the part of the monomer, and on one side it has NH group and the other side it has a carboxylic group. Here again this has NH and carboxyl, here NH and carboxylic group. This portion is actually for the amino acid, because amino acid has amine portion and carboxylic group attached to the monomer, the hydrocarbon inside. On both sides it has both the functional group. Whereas in nylon we had dicarboxylic acid and diamine, and if you follow the pattern over here, you can see this rectangle on both sides we have carboxyl, and this on both sides we have NH. This means this was a diamine and this was a dicarboxylic. This is a dicarboxylic, this is a diamine, and that is why we call it a nylon. So this is the structure of the nylon, and this is the structure of the protein. So each amine acid has carboxyl and amino group. Each amino acid has carboxyl and amino group, and whereas in nylon each monomer has two carboxylic group on both sides, this is dicarboxylic, and two amino on either side, so this is diamine. Now we come to the esters, another polymerization we are going to discuss, and the linkage over here is, you can see carbon double bond O. Esters we have already discussed. You can find the link, you can find this in the given link. So terylene is artificial, monomer are dicarboxylic acid as we have used in nylon, and acid with two carboxylic group, and a diol, that is an alcohol with two OH group. This is the dicarboxylic, and this is a diol with two OH groups. Again see, I have drawn the lines like this and drawn the lines like this, which represents part of the monomer, and they show that they are different from each other. So we are going to study the polymerization process. Here you can see the dicarboxylic acid, here you can see the diol, this is another diol, dicarboxylic acid and diol. Condensation, that is removal of water molecule. As you can see, I have represented this water molecule H from the alcohol part and OH from the carboxyl, H from here and OH from here. Same way, similarly OH from here and H from here, and this as it goes on. So I have just dotted line, added dotted line this. Now this is the condensation polymer, that is the terylene. Now you can see this is the portion which is showing the ester, this is the ester, this is the ester linkage, and on both sides of the rectangle you can see two carboxyl groups, C double bond O and C double bond O, and on this rectangle you can see both oxygens over here with the removal of two NH2O molecules. Why we write N? N is actually the total number of the monomers, whereas with two monomers, that is from here, if you can see, one water molecule is going to be eliminated from here and one water molecule is going to be eliminated like this. So two water molecules are going to be eliminated. Now this is the repeat unit. Terylene is a polyester as it contains many ester linkages. You can see the ester linkages over here. Now some examples of that is preparation of nylon 6 monomers. These are just the examples. Why we call nylon 6? Because you can see these are the 5 CH2 groups and 1 C over here, so all together they make 6, and this also like, and when they are going to condense together, this is the removal of water molecule from here, and these are the repeat units. So it comes out like this. So its name is called nylon 6. Then we have another one, that is 1,6-diamine. Now we have 6 carbons over here. So one NH group is attached on this side, that is to the first carbon, and one NH2 is attached to this carbon, so this is carbon 6. So if you draw a chain, first carbon and the last carbon. This is 1,6-diol chloride. Here this was actually the carboxylic group, of which OH has been replaced by Cl. So you need not go into the geometry of all this at this stage, and also you just know the name, don't remember the name, just you have to see how they are going to condense with each other. So a Cl molecule from here and H from here, Cl from here and H from here, and this is the linkage. This is 2 and HCl. Remember in the beginning when we were talking about the condensation definition, we said removal of a simple molecule like water. So it doesn't mean that it is always water. It can be HCl if over here instead of OH we have Cl group of the carboxylic acid. Now we come to fats. Fats are big molecules of esters possessing same linkage as terylene. Fats are macromolecules, not polymers. You will just learn right now. Fats are made by long chain carboxylic acids and glycerols. Now these are the carboxylic acids. You can see one carboxylic, second and third. I have written plus inside because these are separate carboxylic acids, and I have drawn these rectangles which are going to show the large number of carbon atoms the chain which can go to C17, C33 and so on and so forth. So there is no need to draw all that. We just have to look at the carboxylic group. Now this is the glycerol, which is also called the triol. You can see 1, 2, 3. If you can see this was a propane molecule, and one hydrogen over here has been replaced by OH, one over here has been replaced by OH, one over here has been replaced by OH. So these are joined with these covalent bonds, and these are the alcohol groups. So OH and H, OH and H, OH and H, when they are removed, it forms a structure like this. With the removal of 3 water molecules, that is from each one, 1, 2 and 3, we remove 3 water molecules. This is the formula of the fat, and right side is condensation and reverse is hydrolysis. You know, fats are natural, they are present in our body, and they are also broken down into the fats. When we eat fats, they are broken down with the help of enzymes into these glycerols and carboxylic acids. Then we have, last but not the least, these are the carbohydrates. It includes all sugars, starch and cellulose molecules. This is glucose. Glucose is actually a diol. On both sides we have hydroxyl groups, and H and OH, then H and OH is removed and it forms actually the starch. If I write H from here, if I eliminate OH from here, and if I eliminate, you can say H from here, and we can say that this is from OH from here. So water molecule and a water molecule, what is left behind is this O and this O over here. So the starch molecule formula, polymer, becomes like this, and with the molecule, with the removal of water molecule from it. Now you can see these are the uses of the addition polymers. Polyethylene is a type of material known as plastic. It is used in making items such as plastic bags, toys, buckets and cling film. Here a little diagram. You can see this is polyethylene, can be easily molded into various shapes, thus many plastic toys are. Now the child is actually playing with the toys, and the toys are not toxic at all, and therefore you can see thus these are some toys over here. He is playing, and here we can see this little girl. It has polyethylene, can be used to make cling film and plastic bags. You know, we mostly use these cling films in our houses to cover the food. Now we come to another use. Now these are some other uses of the addition polymers. Here this is the Perspex, which we have discussed earlier. Just the formula you can see. It is used, the windscreens of cars are made up of Perspex. Perspex is a transparent and not as breakable as glass. This is Teflon, which I have already discussed. These are the frying pans, are coated with a layer of Teflon. Teflon is heat resistant and has non-stick properties. This is polystyrene, and these are very common, you are aware of it. This is the formula, this is the phenyl group, phenylethene. Polystyrene is hard, light and brittle. It is used to make disposable containers. Now brittle, the word brittle, you must have experienced that it breaks into pieces. Now this is polyvinyl chloride. This I have already discussed. This is chloroethene, and this is the formula of its polymer unit. Polyvinyl, which is known as PVC, polyvinyl chloride, is used to make pipes, raincoats, thin gloves and flooring mats. So these were the uses of the addition polymers. Now we have the uses of synthetic fibers. Nylon and Terylene are synthetic fibers. Some of their uses are clothing, curtains, parachutes, fishing lines and sleeping bags. Now here this sleeping bag is made up of Terylene. Unlike natural fibers, synthetic fibers do not shrink when exposed to water. Here you can see synthetic fibers are usually strong and can be drawn into long wires, thin strands without breaking. Thus they can be used to make fishing lines. Now these are the clothes over here. Clothes made from synthetic fibers are shrink proof and crease proof. They are also easier to wash and dry. Here I am going to discuss the problems which are related with the plastics. We have already discussed the uses, but now there are certain problems which are related with the plastics, that is, they can be cause of pollution. Plastics are non-biodegradable, that is, they cannot be broken down by bacteria in the soil. Hence, the biggest problem with plastic is what do we do with them after we have finished using them. So you know, the plastics which are non-biodegradable, they are not, they stay as it is in the soil for a longer period of time, and they can cause a problem if they are thrown into the water, if they are in the air, if they are burnt in the air, or if they are just thrown like this. So they cause lots of problems. So what are the pollution problems caused by the disposal of plastics? Let's talk about the air over here. Plastics are mostly flammable. Upon incineration, they produce poisonous gases. Here you can see, for example, PVC produces corrosive hydrogen chloride gas on combustion. And here, very common problem for the countries which are not advanced. You can see the people, they keep on burning the trash, and when they burn the trash, there are lots and lots of toxic fumes which come out. That is, the plastic shopping bags, plastic, other things made up of plastics are burnt inside it, and they cause a pollution problem in the air. That is, they give off very toxic gases which can often cause irritation in our respiratory system, and can also cause not only respiratory, but they can cause irritation in our eyes and in our skin also. Then we have land pollution, that is, plastics. You can see so much plastic and trash is thrown on the land. Now these were on the top, these are the incinerators, that is, here the trash is burnt. Mostly we can see these incinerators in hospitals where they burn the toxic material, and these are the tall chimneys which can throw the toxic fumes on the upper layer, not over here, so they can cause a breathing problem if they are not tall enough. Plastics do not decompose, thus burying plastic waste in landfills leads to an increasing amount of build-up of the waste. So very common practice for these plastics which do not compose is that they actually collect all the plastics, and wherever there is a need of landfill, they add up all the trash over there and they just cover it. So this is also a problem of the build-up of the waste. Now the most important, that is water pollution. And the water pollution, actually, plastics thrown into the sea endangered marine animals. For example, turtles often mistake plastic bags for food and choke on them. Plastics may clog up the rivers and drains, which might become breeding grounds for mosquitoes. So these are some of the reasons, some of the problems of the plastics. So how can we dispose of plastics? The best way to deal with plastic is to reuse or recycle them. And they can also, companies are now making up plastics which are actually biodegradable. You can see that is, the shopping bags are converted into some different types of shopping bags which are actually biodegradable, or instead of using plastic bags, we can use paper bags. And in order to educate the people, there are recycling bins used, which is convenient at convenient locations such as schools, offices, public places, to encourage people to recycle waste materials. But actually, for this we need to educate our public also, in order to throw the trash in a proper way. So now thank you very much. and I hope you have understood my lecture on this polymerization, macromolecules. After this, I am going to come up with another topic, that is acid, bases and salts. So I hope you have liked my video